Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with our binary search playlist, which is the part of the ongoing Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. Please do check it out. Otherwise, you'll end up missing out on a lot of things. So the problem that we are going to solve today is Koko. Now, Koko eating bananas. Koko is an individual who is going to eat bananas, but she has a problem in hand. And the problem is, he'll be given piles and basically n piles, and every pile will have certain number of bananas. For an example, if you take this one, on the first pile you have 3 bananas, on the second pile you have 6 bananas, on the third you have 7, and on the fourth you have 11 bananas. And Koko will also be given a parameter h, which is basically the number of hours. So over here Koko is given 8 hours. Now Koko's task is to eat bananas in the fastest manner, but she can only take at max of 8 hours, not more than that. So your task is to tell Koko the minimum integer k. So you have to basically find out that minimum integer k such that Koko can eat all bananas within h hours. Now what is k? K is nothing but number of bananas she will eat per hour. Let me explain you. So imagine I tell you that Koko is eating 2 bananas per hour. So for the first pile, the number of hours that Koko will take will be, so there are 3 bananas in the first pile. Now remember, Koko cannot move to the next pile before finishing up on the previous one. So if you have 3 bananas and you're saying 2 bananas per hour, so Koko will take 2 hours to eat these 3 bananas. Ideally, it will take 1.5 hours, but whatever hour has been wasted, like you cannot say, okay, carry the 0.5 to the next pile. That cannot be done. So if you're saying 2 bananas per hour, okay, for the first hour it will eat 2, and on the next hour, since the pile just has 1 banana left, it will take that 1 bananas. So eventually on 2 hours it can eat 3 bananas. So I can say Koko will take 2 hours to finish up 3 bananas. I know it will take 1.5, but we always have to consider the ceil value of hours. So over here, if I have 6 bananas and I'm saying 2 bananas per hour, how much hour will it take? It will take 3 hours, very sure. What about 7? Now this has 7. So Koko will ideally take 3 point something. But again, if you're taking minutes, it should always be considered as hour in a single pile. So the number of hours will be 4 hours. Why? Because 7 bananas and 2 bananas per hour. So it will be like 2 plus 2 plus 2. This will be in the first 3 hours. And in the remaining one, he'll eat 1. So it will be like 3.5 hours. But you always have to take the ceil value of hours. So it will end up taking 4 hours. Now in this, we have 11 bananas. So it will end up taking 5.5 hours. Which is, again, you take the ceil value, that is 6 hours. And if you sum it up, like the total time that Koko took was 3 plus 2, 5 plus 4, 9 plus 6, 15 hours. Koko ended up taking 15 hours. But the problem stated, you have to find the minimum integer k such that she can eat within 8 hours. So if you take 2 bananas per hour, Koko will end up taking 15 hours, which is not acceptable because 8 hours is the deadline. So obviously this is not possible. Hence what Koko will do is, Koko will probably try to increase this to 3 bananas per hour. So when he takes 3 bananas per hour, this will be taking 1 hour for sure because there are 3 bananas in that pile. This will take 2 hours. What about this? This will take something like 2 point something. Thereby 3 hours. What about this? This will end up taking 4 hours if I'm not wrong. Am I wrong? Yeah, this will end up taking 4 hours. So what will be the overall value? So if you sum it up, it will be 4 plus 3, 7 plus 2, 9 and 10 hours, which is again not under the deadline. So maybe I can just increase this to 4 bananas per hour, and this will take 1. This will again take 2. This will take 2, and this will take 3 hours. Let's see. 3 plus 2, 5 plus 2, 7 plus 1, 8. This is exactly matching the deadline. The deadline was 8 hours. If I eat 4 bananas per hour, I'll end up taking exactly 8 hours, which is okay. Can I take 5 bananas per hour? Yes, I can. then the hour will reduce. If I take 6, it might reduce. If I take 7, it might reduce more. If I take 8, it might reduce more. But the critical point of the question is minimum. What is the minimum bananas per hour that you can eat? You tried with 2, did not work. You tried with 3, did not work. You tried with 4, it did work. So the minimum possible bananas per hour that he or she can eat is 4. Thereby, the answer is 4. So what is the first solution that comes to your head? The extreme brute force that I can think of is start with 1 banana per hour because that is the least I can eat, and figure out the total time. If that exceeds the deadline, say it's not possible, increase the count and move to the next integer, which is 2. If that also exceeds, increase the count, move on to the next. If that also increase, move on to the next. And whenever you find an integer which is under the deadline, you say this is possible and you stop and you return that as an answer. And over here 4 was the answer, so I stop at 4. This is kind of starting with 1 and keeping on increasing, and we stop the moment we get our answer. But the question is, what can be the maximum possible answer? Like if I ask you, like I know the minimum can be 1 banana per hour, but what can be the maximum? Because I'm kind of trying to figure out a range. What can be the maximum? Can I eat 13 bananas per hour? I can, but if I eat 13, this will take 1 hour, this will take 1 hour, this will take 1 hour, and this will take 1 hour, which ends up taking 4 hours, So 13, does it make sense? You will say, maybe you can take 11, because even if you take 11, it will still take 4 hours. But the moment you take 10, it might take slightly more than 4. So thereby, the maximum will be 11, because even if you take 11, it is taking 4 hours. Even if you take 12, it will take 4. Even if you take 13, it will take 4. Even if you take 14, it will take 4. So the maximum banana in any of the piles is what you can eat as a maximum per hour. So I can say one thing for sure. My answer will always lie between 1 and 11. I just have to figure out the minimum possible integer in this range. Either the answer will be 1, or like the answer will definitely be from 1 to 11. So I know that thing for sure. So what I'll do is, I know my answer will be from 1 to the max in the array. And you can easily figure that out. You know how to find a maximum element in an array. And what will you do after that? You'll be like, okay, so once you figured out the max, this is the number of bananas you're eating. So how much time will you require? That's important to compute. So what you can do is, maybe you can write a function that computes. So what you can say is required time. Maybe I'll write a function. Please compute me the required time. So I'll pass him the piles of bananas. I'll tell him this is what you can eat per hour, and you give me whatever time you require. So this required time will be very easy to code. So I have to write the function which computes the total hours. It's going to be super simple. I write the function, I give him the pile of bananas, and I tell him that this is what you can eat per hour. After that, I will basically write total hours equal to 0, and I will go through the entire array, which is going from 0 to the last element, which is n-1, and I know at every pile, it's gonna end up taking the seal of array of I by the hourly. That's very obvious, because even if it's 3 point something, I always take 4. Even if it's 6 point something, I always take 7. So I can say the total hours will be added, and eventually at the end of the day, I can return the total hours like this. Correct? So this will be returned as the total hours, and this function will compute the total hours given the hourly rate at which you eat. So this function is computing you the total hours. Can I say if the required time is lesser than the given deadline, this is your answer? This is your answer. Very much sure. And you end up. So this is quite simple. Perfect. It does work. But what is the time complexity? Can I say the time complexity will be bgo of, what is this running for? Max of array element, whatever max the array has, multiplied with, you're basically running a function where you're going across the entire piles of bananas. So thereby, it will be bgo of n. Hence, the time complexity is maximum of array element into n. Will this run? No. This will end up giving you a time limit exceeded. So how do you improve this? So if you remember, I told you in the initial classes, we can apply binary search on answers. Whenever you see a pattern, over here you're seeing a pattern. You're seeing a pattern, isn't it? What is the pattern? You know the range. You know the range in which your answer will lie. So if I go over here, for this particular example, you know the range was 1 to 11. 1, 2, 3 was not possible. 4 was the first element where you can eat everything under the deadline. 5 was also possible. 6 was also possible. 7 was also possible. 8 was also possible. 9 was also possible. 10 was also possible. So everything was possible. You're seeing a pattern. Not possible to possible. Now what you need to figure out is this particular thing, which is the least value at which it was possible. Can you apply binary search is my question. Yes, you can. Whenever you have this scenario, when you're sure, not possible and possible, you're sure about that, what you can do is, you can always replace this linear search, because this is what you're like. This is a simple linear search where you're traversing from 1 to 11. The simple linear search can be replaced by binary search, and this is where you can implement binary search. Got it? Whenever you're solving questions related to binary search on answers, it's very important to figure out the range. Like over here, I know the answer will lie between 1 to 11. Now the question is, if you take 1 to 100, will the binary search work? Yes, it will work. It will also work if you take 1 to 100. But the key over here is to take the minimal possible range so that the time complexity is reduced. Whenever you're deciding the range, as long as your answer is lying inside the range, as long as your answer is lying inside the range, binary search is going to work. But whatever range you're taking, the length of the range will determine the time complexity of binary search. So it is very important that you make sure that you take the correct range so that the time complexity is minimized. So over here, we know that the range will be from 1 to 11. So I'll quickly write down the numbers. So I've written down the numbers, and what I can do is I can keep the low over here and I can keep the high over here. So I've written down all the numbers, and the low will always be pointing to the leftmost point and the high will always be pointing to the rightmost point. What is the first step? Figuring out the middle, and the middle will be 6. Why? Because 1 plus 11 by 2, 6. Super simple. So you have 6. So what I'm saying is 6 possible? If it is possible, then I will think afterwards. But let's check if 6 is possible. So I'll be like, okay, this will take 1 hour. This will take 1 hour if I take 6. This will take 2 hours. This will take 2 hours, isn't it? Because that is what it will take. What will be the total? 1 plus 1, 2 plus 2, 4 plus 2, 6, which is under the deadline. So what I'm saying is 6 is a possible answer. 6 is a possible answer. Maybe you can just store it in a variable, but you'll understand without variable also this will work. So you can store it in a variable saying, okay, 6 is possible. Now let's go back to the question. It's asking me to find the minimum. So will you go on this side or will you go on this side? Obviously this side, because taking 7, 8, 9, 10, 11 will never help. Thereby, you'll end up eliminating this portion. And what you will say is, okay, this is no more possible. Thereby, I'll end up taking high to this. Because taking 7, 8, 9 will not make sense because I need the minimum. Perfect. I have 1 and 5. Again, find the mid, and the mid will be 3 this time. So when the mid is 3, what will you do? Well, again, find the number of hours taken. This will end up taking 1. This will end up taking 2. This will end up taking 3. This will end up taking 4. And the total will be 10. 10, yeah. Which is greater than this particular 8. Thereby, what you can say is this is not possible. This is not possible. Hence, the answer will not be updated. And if this is not possible, if whenever you're eating like 3 bananas and it's not possible, eating 2 bananas will also take more. Eating 1 will also take more. Thereby, you eliminate this portion and this low will move to 4 this time. Just look at how binary search works. Next, find out the middle. This time middle will be 4 plus 5 by 2, which is 4.5. That's 4. So the mid will be pointing to 4 this time. Let's again compute the total number of hours and see if it is fitting in our deadline. This will be 1. This will be 2. this will be 2, and this will be 3. So if I add it up, 1 plus 2, 3, plus 2, 5, plus 3, 8. It's fitting my deadline. It's fitting my deadline. So what I'll do is, I'll update the answer to 4 because I've got a smaller value. Remember, you moved left from 6. So whatever you will get will always be a smaller entity if it is satisfying the deadline. So I update 4. What's the job? If you're saying this is possible, 5 is also possible. So you have already taken the minimum. So thereby, the high has to move because you eliminate the right part. So the high has to move 1 before the mid, 1 before the mid. And this is where the binary search will end. And this is where the binary search will end. I'll just erase it so that you can get a clear idea. The binary search ends because the high has crossed the low and the answer is stored as 4. So you can directly pick up the answer from this variable, or if you carefully observe, this was not possible, this was not possible, and these were possible. And low was initially standing at a point which was not possible. High was initially always standing at a point which was possible. Where did they end up at? If you carefully observe, high will always end up at the opposite polarity. It was possible, it ended up at not possible. Low was not possible, it ended up being possible. Opposite polarity. This is how you look at binary search. It was asking us where it was possible. So if the low was standing at impossible, the low will always stand at possible. Thereby, the answer will always be low. This is how you figure out. It's always the opposite polarity. If you keep on doing examples, you don't need to take this answer anymore. Without answer also, you can just return the low and that will be your answer. I hope you understood it. So I hope you have understood the entire logic. Now it's time to write down the pseudocode. It's going to be super simple. Binary search, given the array, given the deadline, low will always be 1. Where will the high point to? The max element. So maybe you can write a function which figures out the max element in that array. I'll leave that to you. Now you'll run while low lesser than equal to high. In case you are still confused about this low and high, you can always keep an answer. And since you need the minimum possible answer, you can always keep it as int max to start off with. Or the max element, whatever you wish to. Figure out the mid. That's the first step. Figure out the mid. Once you've done this, now figure out if this what time is it taking. So maybe I can say total hours it takes. Write a function where you pass the array. Write a function where you are passing this array and this hourly banana eating rate. And if you remember, we have already written this function. Yes, the same function. After that, you say, hey, if total hours is under the deadline, I know this can be my possible answer. This can be my possible answer. And I need to look for minimum. So I will go ahead and eliminate the right. Perfect. Or else, no, it's too small a value. Please increase. Low equal to mid plus 1. Perfect. Hence the while loop will end here. Hence the while loop will end here. And this is how the binary search will look like. Now, if I ask you about the time complexity, what will be the time complexity of this particular code? I'm doing the same function, which is taking a bgo of n. So I'm still doing a bgo of n. But the linear search took the entire range, like you did run a for loop. We have replaced that with a binary search. So this will take logarithmic of what is the range size. The range was from 1 to 11. Or can I say the range size was max element? So logarithmic of max element, because that was the range size. Because the range in which you did a binary search was from 1 to 11. So the number of elements were 11, which is the max element. So the binary search will take logarithmic base to 11. Thereby, log base to 11 into the function, which is counting the total number of hours. So let's quickly go back to the code editor and look at the code and the subtle changes that you have to do. By the way, you can find out the problem link in the description and you'll find out C++, Java, Python, JavaScript, all the codes in the notes given below. So this is a simple binary search. The only thing that you have to take care is when you're doing the ceil, Make sure you convert this to a double and this to a double, because if you're doing integer by integer, it will give you an integer, and when you send an integer to ceil, it will also return you the normal integer value. So make sure to just typecast before dividing so that it holds that double value, and then you can pass it on to the ceil so that you get the ceil value. That is very important. So what I'll do is I'll quickly go ahead and submit this, and yeah, this is the find max function. I hope you can write it. So we are done with this. So I hope you've understood this. The main concept over here is to determine that range and to figure out where it is possible and where it is not possible. Once you've figured that out, you can solve every problem on binary search and answers. This is my guarantee. And yeah, in case you're still watching, please do consider giving us that like. And if you're new to our channel, what are you waiting for? Hit that subscribe button. And if you haven't followed me on Instagram, Twitter and LinkedIn, all the profile links will be in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.